Our objective for today, I can multiply and divide real numbers. Read together, 1, 2, 3. I can multiply and divide real numbers. So today we're going to finish off with this section of real numbers. So on your Frayer model, in the center of your Frayer model, what are you going to write? Real numbers, that is correct. Real numbers. And I'm going to give you 1 minute to fill the Frayer model up without looking at your notes. Write your definition. Give me 2 examples, 1 non-example, and a hashtag, please. Copy that and go. All right. Let's see. Does yours look something like that? Make sure on your definition it doesn't just say number line. It has to say what? Real number line. Because is there any other type of number line? Yes, because these are what? The non-examples are known as what? Imaginary. That's why there's another number line that you're going to be using. All right, I'll give you time to do that at home. That would be your problem number 7. Notice on the agenda it said 7 problems, but you only copied 6, right? So the 7th is to finish the Frayer model at home. Copy these steps under your Frayer model. So steps. To multiply and divide integers, I wrote integers, but it could be also real numbers. I what? Step number 1, identify if the result is a positive or negative. Step 1, identify if the result is a positive or negative. And here goes the only rule to remember for multiplying and dividing numbers. If both numbers have the same sign, the result is positive. If both numbers have the same sign, the result is positive. So what if they don't have the same sign, everyone? Bam, Jason, let's go. That is correct. They're negative. Step number 2, then you do your computation, whether multiplication or division, and at the end, simplify. Copy that. I'll give you some time. Okay, I don't know if you noticed, I started step 1 instead of doing computation. What am I asking you to do first? Identify if the result is a positive or negative. Now, let me take you back to last year and 6th grade. Remember when you turned in a paper, whether it was a quiz or a home play, and then you got it back and they marked it wrong? And you're like, I thought I had it right. What was wrong? The sign usually, is that correct? Hands if you got something like that in the past. Yeah, me too. I've had it also in the past. But guess why? Because when we are in the middle of a test or a quiz or whatever the case, we're so focused on getting the computation correct that we forget about the sign. Julian, set that aside, please. Thank you. All right. So today I want us to jolt our brain to begin first with the sign and then move on to the computation part. Okay? All right. So look up to the screen. Now, before I move on, though, let me do a quick review of this next term. Look up, please. Who remembers this term? Reciprocal. Okay? Or some of you are like, doesn't really sound okay. How about multiplicative inverse? Does that ring a bell? They're both the same thing. So what is the reciprocal? Just to refresh your memory, here it goes, I'm going to go over it. The reciprocal is a number that when multiplied times another number, the answer is 1. For example, let me think of a random number. 23, Michael Jordan. I need to multiply 23 times a number so that the result, the product, is 1. Look up to the screen. The reciprocal of 23 is 1 over 23. Now, why is that? Let's see. I can write this as 23 over 1. Does everybody see it? So let's see. What is 23 times 1? 23. What is 1 times 23? 23. Therefore, 23 over 23 is what? A giant 1. Is it coming back? Yes? What if I gave you 5? Tell your neighbor the reciprocal of 5. That would give us a product of 1. Okay, Charlie, go. 1 over 5. And if you got that, yeah, right? Because this is 5 over 1 and so on and so forth. Let me give you another one. How about if I gave you -8? Tell your neighbor the reciprocal of -8. That would give us a product of 1. Talk it over to your neighbor. Okay. Esmeralda, go. 1 over -8, because we can write this over 1. Everybody following? Let me give you one more. 2/3. Tell your neighbor the reciprocal of 2/3. That will give us a product of 1. Melanie, go. 3 over 2, because 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is 1. Everybody remember the reciprocal? Okay. So I just wanted to refresh your memory on those. Now let's move on to what we're going to practice with multiplication and division. Copy these, please. Just copy them. Don't do anything else. I'm going to show you the process. Okay? You're saying, but these are easy, Mr. Q. I get it. I know. But I want to make sure that we start our noodle using the same process that I'm asking you to use. Copy that, please. I'll give you some time. All right. Look up to the screen. Writing utensils down. Here it goes. Pablo, step 1. What shall I do? Read your notes. Read your notes. Identify if it's positive or negative. All right. So you need to slow down your noodle and start thinking about it first by getting the sign correct. So here we go. Look at it. Are they the same sign? The answer is negative. Are these the same sign? The answer is, so I leave it as is. Look at this one. Same sign? The answer is, and now I can compute. What is 35 divided by 5? 11 times 4. And 6 times 7. Did I have to worry about the sign? No, I did that at the beginning. Does that make sense? Copy that, please. All right, do this next one by yourself. Last one of these. They're like, Mr. Q, these are so easy. I know. I get it. I understand. But I just want to make sure we start off by doing our little jolt in our brain and slow down with the computation. Start with the signs first. Okay? All right. Nanelle, what'd you get? Positive 12. And so you got that? That is correct. Are these the same sign? Yes, it's a positive. 48 divided by 4 is 12. We get that, yes? Okay. Now, before I move on to division, but now in regards to division of fractions, look up to the board, please, to the screen. Example, Shazam Q. Don't copy this, just pay attention. Now, in the past, I'm pretty sure everybody did these. 2/3 divided by 1/2. Yes? And some of you, your teachers actually showed you a little method of doing that so you wouldn't forget. Yes? Your teacher taught you a method that said what? Keep, change, flip. Did anybody learn that? Yeah. However, most of you don't remember why you flip. That's what I'm going to show you today. Some of you did learn it, but you probably already forgot it, so I'm here to refresh your memory. But now I'm going to tie it to algebra. Yeah, let's go. All right, guys, here we go. Welcome to algebra. Ready? All right, so here we go. This is a definition. You're like, okay, yes. Let me explain the definition. Q stands for quintanilla. Yes, aside from quintanilla, it stands for quotient. Quotient is a result of a division. Everybody understand so far? But we also use that symbol to represent all rational numbers. What are rational numbers? Any number that can be represented as a fraction. So let me go over the definition. Look up, please. It says, quotient or rationals are the set of all fractions. Do I have a fraction here? All fractions where m, here's m, is an integer and n is an integer. However, n cannot equal to what? 0. So the denominator cannot be 0. And last year, some of you covered slopes. Remember slopes? Some of you? Yes? Kind of, sort of? All right. Once again, the Q represents quotient, which is the result of a division. The Z's are what? Integers, which means that integers are all m and n. However, n cannot equal 0. Are we there so far? All right, so now watch. Now let's go to this, and I'm going to apply the definition. Question. Do you agree that this divided by this is the same as this over that? Do you agree with that? Yeah, right? But can we have fractions over fractions? What does the definition say? That these have to be what? Integers. So is this an integer? No. Turn to your neighbor. The smallest integer is 0, right? What would be another? This can't be 0 because it's on the denominator. Tell your neighbor what would be another smallest integer that we can change this to. All right. I heard 1. Can I change this to 1? Now think about it. What can I multiply this to make it into a giant 1? Tell your neighbor, please. That is correct. The reciprocal, which is 2 over 1. However, whatever I do to the denominator, I need to do to the numerator. So I go 2 over 1 over here. So question, what is all this divided by 1? What is all this divided by 1? All that, right? Look what just happened. We went from here now to here. Does that make sense now? Talk it over with your neighbor and let them know what happened here to get to this part, please. Everybody got it? Okay, once again, we needed this to be a whole an integer, right? What was the smallest integer? We said a 1. So we multiply times the reciprocal, yes? And whatever we multiply this, we multiply this. So question was, what is all this over 1? All that. Is that correct? Do we need to write the 1? No, there it is. And what just happened? We changed that to this because of the definition of quotient. Okay? Now, do you need to use that process? No. I'm just showing you where it came from. But you already know how to do the division of fractions, yes? All right. So once again, home plate for tonight. Piece of cake. So now you know how to do number 6, yes? And all these. All right? Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Finish up that prayer model at home for real numbers. Okay? Bye.